Welcome back to another video on AA learning. Today we're going to stick with a math topic, but this time we're going to venture off more to like algebra, and that's going to be of slope-intercept form. So slope-intercept form, it's mainly taught in like algebra 1 or like algebra 2 class, but it's definitely like a key concept in algebra that you guys have to know. So before we get into like slope-intercept form, you guys need to know a basic topic of what is a slope. Okay, so what a slope is, it's the rate of change, and that basically means how much does the y value change for a given change in the x value. Okay, this definition might seem kind of wordy, but like I'm gonna just demonstrate what that means to make it more like hopefully more clear. So let's just draw a normal graph right here and a linear equation. So we have this linear graph drawing that I have, and let's say there's this point right here and there's this point right here on the graph. So let's say I'm just gonna make up points. Let's say this is 2, 1, and this right here is like 5, 3. Okay, you guys need to know this is the x and this is the y. The same for this one. So what the slope would tell us is by how much these values are actually changing. So the slope can actually be written in two different equations. So the first equation is seen as rise divided by the run. So what this equation basically is, it's basically trying to tell us the rise by how high of a y value or low of a y value the graph is changing, and how much to the right or to the left we're going for our run. So that's one of the ways we can find slope. The other equation I think is more clear for us, and that would be this equation right here. y2 minus y1 divided by x2 minus x1. This is the one that I would recommend we use more, because it's more clear. So let's just use our given values right here, the made up values I have, which was 5, 3, and 2, 1. Okay, so now we're gonna use this one just again to be clear. So let's label this as our x2 and y2. Again, it doesn't matter. I could have labeled this x1, I could label this x1 and y1, but I just chose x2 and y2. And here I'll just choose x1 and y1. So let's simply plug these values into the equation we have here. So our y2 value, which is 3, minus our y1 value, which is 1, divided by our x2 value, which is 5, minus our x1 value, which is 2. So that would be equal to 2/3. So that would be our slope for this like hypothetical graph that I've created. So again, these are two topics you guys have to know when going into slope-intercept form. So again, just as a quick like rundown, the rise is basically the change in y, and the run is the change in x, and then this is the other formula: y2 minus y1 divided by x2 minus x1. And you should use both of these when you have like two definite coordinates, as you guys know. Okay, let's get into the slope-intercept formula. Okay, so the slope-intercept formula is written as so: y is equal to mx plus b. Okay, let's label all the parts. So the m, that's equal to the slope. So that's where we find that's where we use our rise over run, or our y2 minus y1 divided by x2 minus x1. So m is equal to slope. And this b value also comes into importance to us. So this b value is actually going to be our y-intercept. So what that would tell us, let's just draw again a hypothetical graph. The b value would tell us what this value is. When x is equal to 0, what would the y value be? That's what the b value will tell us. Okay, and remember, you can find the m, the slope, using the rise over run or the y2 minus y1 divided by x2 minus x1. And one thing I forgot to mention about slope is that slope can be positive, negative, 0, or undefined. So a positive graph usually will shoot upwards like this. That will usually show that the slope is positive. It'll indicate that the slope is going up or increasing. The graph is increasing. And a negative slope will usually go in a downwards motion, and it'll indicate that the slope is usually negative. And then a slope with 0 is going to usually be just a flat horizontal line. That's just going to be the b value basically. And then an undefined, I'll just write UND, undefined slope is basically going to be vertical. It's going to be either shooting up or shooting down. So make sure you guys remember these for like behaviors of slope. Okay, let's get into an example problem here. So our first problem that we have is, I'm going to label this 1, this example 1. Y is equal to 2x plus 3. Okay, so remember our slope-intercept form or formula. So it was y is equal to mx plus b. Let's label the parts. So we have the y and the y, those are the same. And we have 2 and the m. And as you guys can remember, m is equal to the slope. So what this 2 is basically telling us is, if we remember, slope is equal to rise divided by the run. So because the slope is 2, it basically says that the rise is 2 and the run is a value of 1. And then we know this b value is the y-intercept. That's when x is equal to 0. What it is basically saying, what is the y value when x is equal to 0? So we know that x has to be 0, and this is going to be positive 3. So the y value is positive 3. Okay, let's graph this out now. So let's draw a graph here. And again, this is going to be a sketch. It's going to be a really rough sketch, so just take it with like a grain of salt. So let's label our axis. We're going to label this 1, 2, 3, 4, 5, 6, 7, 8. And then our other one, we're going to do 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, all we have to do is plug the points that we know. Okay, so we know the y-intercept is going to be 0, 3. So let's, where's the x is equal to 0? Right here. And then let's go up 3. 1, 2, 3. So that we have a point right there. So now in our equation, y is equal to 2x plus 3. Let's plug in a value of 1. Because we plugged in a value of 0, that would give us 2 times 0 plus 3, and that's why we got our y value of 3 here. So now let's plug in a value of 1. 2 times 1 plus 3. So that's just the same as 2 plus 3, and that's equal to 5. So remember, we said the x is 1, so 1, and when we input an x, we get an output of, when we input an x of 1, we get an output of y of 5. So let's go over to 1, and let's count 5. So 1, 2, 3, 4, 5, and we have 1 right here. So we would just create a dot right there. Now, again, this is going to be a rough sketch, so I'm just going to connect these points, and then just draw a line like so, and then connect it like that. So depending on what your teacher says, you guys might have to do the same for the negative side of the axis. So again, if you wanted to do negative, let's just do an example here. 2 times, let's say negative 1, plus 3. So 2 times negative 1, we know that's negative 2, plus 3, we know that's equal to 1. So we'd have a point right there. Again, it's a sketch, so take it with a grain of salt. Okay, so that is how we would draw our graphs. And as you guys can see with our graph, our rise over run takes into action here. So we have a rise of 2, so we go up 1, up 2, and then we have run of 1. And that's how we got this point right here, from this point to this point. And then if we continue this trend, it would be up 2 again, and then run 1. And that would give us this point right here, 2 comma 7. And that would make sense, because we have, when we multiply 2 times 2 plus 3, that'd be 4 plus 3, which would be 7. So hopefully that made sense. I'm going to go over another example where we draw a graph, and then we're going to go over some different types of examples that involve slope-intercept form. Okay. Let's go over a little more complicated one. We're just going to label this 2. And this is going to be y is equal to negative 1/2 x plus 4. Okay. So let's just draw our graph again, because we're trying to draw a graph here. That's our goal. Okay. So let's identify the parts. We know the equation y is equal to mx plus b. Okay, we know our m is the slope. So what is the m in this case? It's negative 1/2. So let's just label that in the corner right here. M is equal to negative 1/2. And what's our b value? We know that's positive 4. So b is equal to 4. Okay. So in this m value, it's a little bit different. So last time we just had a 2, and we know our 2 over 1 is the same as just 2, right? So in this case, we have a fraction of negative 1/2. So our rise value, we're going down negative 1. And our run value, we're going to the right, 2. So make sure you guys remember that. This negative also comes into play when you guys are using using the slope. So using the knowledge we know now, let's try to draw this. Again, this is going to be a sketch, so take it with a grain of salt. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do up to 9 this time. And then, let's do 10. 10. Okay, and then here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so those are our coordinates, and now let's just plug in points. So we have 1 over 2x negative. So we know y is equal to negative 1 over 2x plus 4. Okay, what I usually like to do when there's fractions, actually let's just start with the y-intercept. We know when we plug in x is equal to 0, negative 1/2, anything times 0, that just becomes 0. So y is equal to 0 plus 4. So you know the y is equal to 4. So 0 comma 4. Let's label that point right here. So x is 0, y is 1, 2, 3, 4. So we can draw a dot right there. Okay. Now, when we have fractions, I like to not include fractions when we're trying to graph the points. So let me show you what I mean. If we plug in 1 here plus 4, we would have negative 1/2 plus 4. And that's more of a messy number for this graph that we have, where we have the axis of going x increasing by 1. So instead, let's do negative 1/2 times 2 plus 4. That way we can cancel out these 2's right here, and it'll be negative 1 plus 4, which is equal to 3. So the coordinate would be 2 comma 3. So let's graph that. 2 and then up 3, which is right here. And let's just do one more point just for clarity's sake. So again, if we do 3, that would be negative 3/2, and then adding that to 4, that would again make more of a mess for our graph. So let's just do negative 1/2 times 4 plus 4. And we're trying to find the y value. Make sure you remember that. So we're saying the x value is 4, and we can cross these out, so that becomes negative 2 plus 4, which is equal to 2. This becomes 4 comma 2 right here. So let's graph this, or graph this sketch. So it'd be something like that. Okay, so hopefully the graphing part, you guys got a hang of it. Make sure you guys, whenever you see like a problem like this and you have to graph, make sure you always first look for the y-intercept. What is that b value? and then graph that so you can set a foundation for your other points. Okay, let's go into our third example. If you guys need more practice, I'll link a practice worksheet in the comments, and it has all the types of questions we'll go through today. Okay, so our third example is going into slope-intercept form when we're not in slope-intercept form. So what does that look like? So we have the equation here, 4y minus 8 is equal to 12x. Okay, we want to go to slope-intercept form. So how do we get that? So remember, our slope-intercept form is y is equal to mx plus b. So let's try to get that to that form. So first, our b value doesn't have any x or y terms. So that looks like it's this -8 right here. So let's move this -8 to this side. So we can add 8 over here. And remember, we did it to one side, we have to do it to the other side. And I like our mx value is 12x, so that's fine being on this side. So this makes the equation turn into 4y is equal to 12x plus 8. Okay, now we don't have any constant in front of the y in our normal form. So let's divide this 4 to this side over here. So divide by 4 here, and divide by 4 here. So y is equal to 3x plus 2. And that is how you got into slope-intercept form. So basically all you guys have to do with these type of questions is just play around with it. See how to get it back to the original form that you know it as, and it should be fine from there. Okay, let's go to our last example, and this is going to be a word problem. So our word problem is a gym charges $25 for a sign up fee plus $10 per month. So our goal is to write an equation for the total cost y after x months. Okay, let me make that bigger. So let's read that again. A gym charges $25 sign-up fee plus $10 per month. We have to write an equation. That's important. Whenever you guys have word problems, underline or highlight the main important part so you guys know what to do. So write an equation. So we know that there's a $25 sign-up fee. Sign-up fee. Okay, so that's going to be important. And then we know that the gym charges $10 per month. Okay. That is also going to be important. So just from reading this problem, it looks like $10 is going to be a constant charge. They're going to be consistently charging that $10 every month. So basically we can label that as 10x, because that charge, the first month is going to be $10, second month you're going to be paying $20, third month $30, and so on and so forth. So that's going to be keep multiplying by depending on how many months you decide to keep your gym membership. And this $25 sign up fee, that's the flat cost. So that's just what you have to pay to sign up. You don't have to keep charging the extra depending on how much more months go by. So surprisingly, that's all we had to do for this. And that would be our equation. So again, we have to have the y, and the y is equal to 10x. The reason it's 10x is because it's $10 per month. This per is referring to multiplication. We know x months. So we don't know how many exact months. If it said after 3 months, then we have to do 10 times 3. But they didn't have a specific month, so it's just x. So we can plug in depending on what maybe the problem asks, something like 5 months later. And then we have to add the 25 because that's a flat constant fee. We're not paying $25 every month for the sign-up fee. It's just one flat service. So yeah, there's going to be some practice problems linked in the comments if you guys need more practice, but thank you for watching.